Hey girls, I just wanted to come on here and give you another example of graphing piecewise functions because I know a lot of people were struggling with this, and I want to make sure that you can go back and watch this if you need to watch it again, or do it in slow-mo, or go back and take notes and fill in any things that you're missing. So let me go through this example and hopefully this will help. So let's say we were trying to graph this piecewise function. The first thing you would want to do is to organize your work nice and neatly by listing out the three equations separately, like this. So each equation gets its own y. It's y equals x minus 3, y equals negative x plus 1, and y equals negative 2. I would put a box or highlight that so that you can keep track. These are the three equations that we're trying to graph. Essentially, we're trying to get all three of these equations on one coordinate plane. The inequalities are going to tell you where to graph each function. So I'm going to put them underneath each equation to keep it nice and organized. Oops. And then underneath each one, I'm going to also put a table with an x and a y. It doesn't have to be very big. Each line only needs 2 points to be able to graph it. You always need 2 points to graph a line. You should know that from Algebra 1 and Geometry. The first point that's going to go in your first table is going to start with whatever number is in the inequality. Same thing goes for the other two tables. Anytime there's a number in the inequality, that number automatically goes into the tables. Now remember, we said you have to have 2 points to graph a line. So this middle equation, or middle table, is already good. It already has 2 points. However, the other two equations, or the other two tables, only have 1 point each. So in order to figure out what other point you're going to put on here, you can pick whatever you want as long as it follows the inequality. So for this one, it just has to be something less than or equal to 0. Look at the equation. It's just x minus 3, so it's not like they're going to get any fractions or anything. Just pick any number less than or equal to 0, like negative 1. For the other one, we're looking at 1 is less than or equal to x. If you read that backwards, it's saying x is greater than or equal to 1. So we could pick something like 2. It doesn't really matter based on the equation. There's no fractions or anything, so you can pick whatever number you want as long as it's bigger than 1. Now to fill in all your y's on all the tables, you're going to plug the numbers that you have in for the x's into the equation that's right above it. So for example, if you're trying to plug in 0 to this equation, you're replacing the x with a 0. So it's 0 minus 3, you get y equals negative 3. Now plug in negative 1. So you would have negative 1 minus 3, you get negative 4. Do the same thing for the next table, but now you're plugging it into this equation. So when you plug in 0, it's negative 0 plus 1. So just 0 plus 1 makes 1. Plug in 1. Negative 1 plus 1 makes 0. Next over here, to fill in this table, you're plugging it into this equation, but notice there's no x in this equation. So what that's telling me is that no matter what the x is, the y is always equal to negative 2. So I can just go ahead and fill in my y, negative 2, on both of these. In order to figure out whether these are supposed to be open or closed circles, you're going to look at the inequality symbol. So this point right here where x is 0, it has an equal to sign. So that means that this point on 0, negative 3 should be a closed circle. When it has an equal to sign, it makes a closed circle. Similarly, this x is 0 doesn't have an equal to sign. So I know this is going to be an open circle. This, where it has the 1, doesn't have an equal to sign, so it's also an open circle. And then this one, where it has the 1, it does have an equal to sign, so it should be a closed circle. These are each of the end points for each piece. These other 2 points that we picked are just extra points on the line that the line is just going through. So anytime a line is just passing through a point, it's a closed circle. So these 2 extra points down here will always be closed circles. Now that we have all the information down, now you just have to figure out how to graph it. So you'll see I started out by making a coordinate plane, and I'm going to start out with my first equation. So first I want to plot the endpoint of this piece is going to be at 0, -3. So I'm going to plot 0, -3, and I see it should be a closed circle. And then the other point on this line that it also passes through is -1, -4. And since it's just passing through that point, I know it's a closed circle. Starting from the endpoint, I'll draw my straight line, pointing to the left. This first piece is usually always going to be the piece all the way to the left of the graph, so it's pointing to the left. Now, you can double check this line. Does this line have a slope of +1 and an intercept of -3? Yes. It goes up 1, right 1, and it hits the y-axis on -3. So I'm thinking this graph so far is probably right. Now let's look at the middle piece. This middle piece starts at the endpoint 0, 1, and it ends at the endpoint 1, 0. They're both open circles. So I'm going to put first a point on 0, 1 with an open circle, and then I'll do my other point on 1, 0, also with an open circle. This is my middle piece, so it's just 2 endpoints. I'll just connect them together. And you'll notice this one, it has a slope of -1, as it should, and the intercept of +1, like it should. Finally, I'm going to graph my last piece over here. It starts out at 1, -2 with a closed circle, and it also goes through the point 2, -2. Since it's just passing through 2, -2, I use a closed circle. So I'm going to start at the end point of that piece and draw my straight line. Notice that this has a slope of 0 because it's like saying 0x. So it's a slope of 0, it's a horizontal line, there's no x in the equation. And this, if you had kept going past the endpoint, it would have hit the y-intercept of -2. Another thing you can double check to make sure you're probably on the right track is looking at this vertically. If you check the vertical line test, it should pass because these are piecewise functions and functions have to pass the vertical line test. Now let's go over the domain and range. So for domain, remember you're talking about left to right. So you're going to be looking at what's the furthest to the left the graph goes. Notice that this arrow is pointing to the left. So since this arrow is pointing to the left, my domain has to start at -infinity. Then, if we were trying to highlight this, I would be highlighting everything over here, and it keeps getting highlighted all the way to here. Now here's where you might want to pause for a second. Is there a point somewhere on this graph with an x value of 0? Yes, even though 0, 1 is an open circle, 0, -3 is a closed circle. So since these are covered by, since the x value of 0 is covered by that open or closed circle, you can go ahead and keep moving on along the graph. So we kind of just jump up to this piece, we keep going, pause here. Is there a point somewhere on the line or somewhere on the graph with an x value of 1? Yes. This third piece has an x value of 1, so I can just hop over that and keep going. And then notice it would go on forever to the right. That arrow is pointing to the right, so my domain goes to infinity. So the domain for this is -infinity to +infinity. The range, however, is a little different. We have to go from the bottom to the top. So now for range, you're going to look, notice this arrow is pointing down. So I would highlight starting at the bottom, but then I'm going to pause here. Notice there's no points between -3 and -2. So for range, my first piece goes from -infinity, since we're talking about y's, the negative infinities are at the bottom, and that piece stops at -3. At -3, it's a closed circle, so I use a bracket. Remember, closed circles use brackets, open circles use parentheses. Just so you know, infinities always get parentheses. Then I skip. There's no points between -3 and -2. My next piece is right here on -2. That whole graph has y values of -2 for that piece. There's nothing besides -2. So the way I write that is I just put a -2 in a bracket by itself. It's not going increasing or decreasing. It's just -2. But then again, I take a jump. There's nothing between -2 and 0. I don't start my line again until 0, and that piece ends at 1. So I know it's going to be 0 to 1 since they're both open circles. I do parentheses on both of them. All right, hopefully that helps you see the domain and range a little more visually, and you can also rewind and get some practice with the graphing part of it. I think organizing it this way will really, really help you guys to keep track of what's going on and just to know where the end pieces are. For me, especially when it's more than just 2 pieces, making the table is a lot better method than doing the whole line and erasing. But that's up to you. If you like to draw the whole line and then erase, that's fine too. But like I said, when it's more than 2 pieces, this method of making the tables and organizing my work like this is very, very helpful. So hopefully it works for you too. Have a great rest of your day. Bye, guys.